Great, thank you. My name is Bernardine. As mentioned, I'm from Carnegie Mellon University's Robotics Institute. And what I'd like to tell you a little bit about today is my interpretation of the real world and what I've been trying to get robots and robotic technology to do in this world. So a lot of people today have mentioned having these extra efforts to inspire kids and to bring technology, use robots as a way to motivate kids to learn. And these are the kinds of kids that I actually like to try and inspire among others. So there's a little girl who is blind in India, and there's a little girl in Zambia wearing an I Love Robots button. So we've been inspiring both girls and boys, but even the conference today, I highlight the girls. To really embrace technology and to interpret technology in ways that are meaningful and accessible to them. I'm going to focus mostly on work we've done for the population that's blind, but there's of course other things we've done. So let me start by just telling you a little bit about my research group, TechBridge World. I grew up in Sri Lanka, and I was really motivated to try and get technology that made sense for the place that I grew up in. And having talked to my advisor, I was a PhD student at the Robotics Institute, so my advisor was Tony Stems. And after hearing about this for 4.5 years from me, he said, Bernardine, why just Sri Lanka? Why not think bigger and why not do it here? So that's how I started TechBridge World. And I started to try and rethink technology in ways that made sense to populations and communities that are underserved by technology. So this has translated into people in developing communities and people with disabilities. I wanted to first make a couple of things clear. So when you guys run experiments for the large part, you guys have a lab and you kind of set things up. And as hard as it is to bring people and get these studies done, my world's a little different. So when I need to run an experiment, I gotta figure out how to pack our bags and meet the luggage limits, go to a place where you can't really book hotels online or by phone. I need to figure out things like how to travel by bus from Lusaka to Mongu without getting attacked by hippos or other wild animals. I need to often provide services like cleaning out labs that have computers so that we kind of build trust with the community before they're willing to work with us. There are a lot of local cultural protocols, giving speeches, gifts that are appropriate, really all to build trust with the people that we're trying to work with and we're trying to understand before we can build anything that's meaningful for them. But it's incredibly rewarding work, and we've learned a lot over the last 10 years doing this work. And you know, things like this, when we sort of show up on a data test and they're already there playing with the technology and doing things that we hadn't even envisioned doing, has been incredibly rewarding. So this is sort of my world. So the results you'll see are a little different from more traditional results. And we really have tried to go around the world. We have two guiding principles. We never go anywhere uninvited, so we always have that respect for the community. We go places where people want us to come and help work with them to do something. And we focus a lot on empowerment, so really working with that community and imparting enough knowledge and setting things up in a way that they can continue. So I'm going to focus for this talk on people who are blind. And I'll give you both a developing world and developed world example. Just so you know that the concept of blindness is really a concept. People, even in the United States, people are diagnosed as blind, but they might have a variety of, sort of a range of visual capabilities. So as one of the O&M instructors told me, he said, unless they really don't have eyeballs, don't believe a diagnosis that's blind. So they might have residual vision, and you get everything ranging from low vision all the way to people who are both deaf and blind, so it's called deaf blindness. And we've worked with that entire range. Just because I have, I'm told, 17 minutes, I'm going to focus on blindness for this. So let's start by looking at an education example. This is our longest running project, and we started working with this school called Mathur in the developing India in 2006. And it was our first exposure to Braille, and the way blind people become literate. So literacy is critical for people who are blind, especially in the developing world. Over 90% of the blind population of the world lives in the developing world. It's often incurable or preventable, but due to lack of resources, that's not the case. And without literacy, there's really no hope for these people to have a rich social life. When I first heard this statistic, and less than 3% of this population are literate, when I first heard this statistic, I said, oh, so this means that if they're not literate, they can't get a job. Well, it's actually worse than that. So in Matru, in the first grade, they learn how to write Braille. They don't get to the first grade till they learn very basic skills like how to clean themselves, how to get around the school. It's a residential school. A lot of the parents don't really have, can't afford to have a blind child, let alone a child. And so they're essentially adopted by the school. And you learn to write Braille in the first grade. And then from the first grade onwards, all your education is based on the notes you can take with that Braille you learn to write. So you cannot pass any of the grades if you can't take notes and actually read your notes and make sense of it. So really your entire education hinges on this one concept of learning to write Braille. And it's at such a young age, and the children are malnourished often, so they don't even have the motor skills that children at that age typically have. So to give you a sense of Braille, and this is why I voted for touch, by the way. Braille is the concept of reading by touch. And it's embossed dots. It's a pattern of 6 dots, basically, for the most part, except China is now moving to perhaps introduce an 8-dot Braille pattern, because it actually takes 3 cells to write Chinese Braille. So Braille is not a language, it's actually an encoding of languages. You get, for example, Arabic Braille, English Braille. You get American English Braille and British English Braille, which is different, of course, and so on and so forth, right? So it's all about figuring out which subset of the 6 dots are raised and interpreting that in the right context. Now, in the developed world, a lot of times you just type this out, and it's easier. But in the developing world, they use what's called a slate and stylus, which is over there. And basically, it's a sleeve, a plastic sleeve. We can't combat with this price point. It's like 10 rupees. So you push a sheet of paper in, you write your Braille, you take the sheet of paper, you flip it over, and you read. So this means that the alphabet you learn for reading is the mirror image of the alphabet you learn for writing. So now think about it. You're in first grade, you're blind, you're in a new school, you're learning an alphabet, so you have to know the alphabet. Then you're learning the reading version of it in Braille and the writing version of it in Braille, and you need to be able to keep all of this together in your head and figure all of this out going forward, right? It's a pretty difficult task. To make things worse, most of their teachers are blind, because this is one of the few ways they can get employed. So we started asking ourselves the question of how can we help improve literacy? And we decided that there was no way we were really going to compete with the technology that was going to really replace the slate and stylus. So what we wanted to do was improve how they learn writing Braille using the slate and stylus. So the delays are listed there, but a big problem is feedback. So how things work in Matru and in similar schools around the world, the teacher will tell you, write these 2 lines of characters. Then the teacher takes the sheet of paper out, and she will be reading, and she will tell you, in the first line, the 6th character, your 3rd dot was incorrect. So imagine trying to now translate that back to a feedback loop where that's going to make sense. This is one of the biggest problems. So what we did was essentially make an electronic version of the slate. And it talks back to the student as he or she learns to write Braille. And we can scaffold a curriculum. So this is just a progression of the devices we've built. And the audio feedback has a huge impact on the student's engagement and the student's retention. And the student can actually play around with this, can be a lot more independent. And the teacher can give more immediate feedback as well because she can hear what's going on in the class. So we had a lot of things that we were trying to do in terms of trying to balance the immediate feedback, We also had to take into account things like children at that age really, when they're blind, the voices, they trust certain voices and they don't others. So we customize the voices to be the teacher's voices to start with in the younger stages. We made sure there was a scaffolding of curriculum that matched the different learning standards. And then we also introduced things like games. So if you've ever written a computer game, now think about how you might write that without having any visual feedback, right? So you have to capture state and scoring and the next thing to do and whatever else you have all in this one audio channel. But you can do some pretty cool things. And we found that actually the games are very popular even among the teachers. So in the off times, the teachers actually take the real tutors and play games, which is kind of cool. So there are other things that we learned along the way. I can't tell you all of them clearly. But we also, our newest version starts with just the 6 buttons and teaching kids this concept of its 6 dots and how that's ordered. And you have to learn the numbering and the understanding that there are patterns of them and so on and so forth. And then you graduate to an intermediate version where you learn to travel from cell to cell. So there are 3 cells. And then also start writing with the slate and start with the stylus. And then sort of the advanced version is all slate and stylus. We have ways of translating the language behind that by just swapping out a character map. That works as long as you have 2 to the 6 or less characters. Once you surpass that, so some languages we have to play around with, it becomes more complicated. Our price point right now is about $100 for the early version. That one needs an external computer. And that's only if you make a batch of 10 in the US. So the actual price point is much lower. And then if we force the computing on board, which is the newest one we're working on, that's around $250 right now. But that will also go down. So this is one of the examples of things we've been working on, and it's been actually operational in the school since 2006, which is really exciting. So as Ayana mentioned before in an earlier talk with cerebral palsy, a lot of this has us been going out, figuring out what works, and then making that work over time. And it's really exciting that we're coming up on 10 years of this technology actually being used. So we introduce it, we set things up, and then we leave, and we've only had to replace devices about every 2 years. And most of the device damage has been just the kids' drool on the devices, and we haven't quite figured out how to prevent the drool from totally killing it in about 2 years. So, there are things that need to be worked on. And this summer, another group of my students will be going to India to work on this. So we've learned a lot of things like don't put wires. Our initial version had a wire that connected the slate and stylus. Well, blind kids are taught to stay away from wires. So yeah, that was a really stupid thing to do. And so we started there. We have come a long way since then. We've tested in multiple countries. So there are these braille tutors being used in several places around the world. Most of the data that we get now is primarily from India, just because we focused on one place to get longitudinal data. Okay, so I want to switch gears slightly since I have about 4 minutes left, and tell you a little bit more about, well, how does this translate to things we do in the developed world? So one of the problems we've been looking at in the developed world is urban travel. And I wanted to give you a sense for what blind adults go through in urban travel in the US. So we've been, as always, we always work a lot with the community. We've worked with a number of organizations and met with, observed, and interviewed a lot of blind people. And this is an example. This is actually my team going through some orientation and mobility training, because that's the other thing we try to do is also get some experience with that. That's Dr. George Zimmerman, not related to the infamous George Zimmerman in Florida, who actually runs the Vision Studies group at the University of Pittsburgh, and he basically trains most of the orientation and mobility instructors, people who teach blind people how to navigate. in the US. So he was training us on how you would navigate with the white cave. And he has this thing called the Zimmerman kit where you can basically wear these goggles and simulate different visual impairments. So it's really very disorienting to try and navigate when you're wearing those goggles. So we've gone through all of that and we've learned a lot about where technology can help. And this is just my map of where those key points are. It's everything from starting trip planning. Blind people rarely leave their house without having a very strong level of planning for where they're going to go and what they're going to do, much more than we do. They need accessible maps, things like tactile graphics or magnified images or so on and so forth. They need to familiarize themselves with environments. Sometimes, depending on their level of blindness, they can do this on their own with technology. Other times, most often, they actually have to hire someone or go with someone sighted. They need to do route planning, transit assistance. I've talked to people who have waited 3 hours to catch a bus just because they couldn't quite figure out where the bus stop was. So they might have been just a few feet away and the bus won't stop until they're like close enough that they identify the person standing with the bus stop. Dynamic guidance when things go wrong, asking for assistance. They want to be able to be a part of that solution. And so this is really important, being able to annotate their maps and share information. One of the things we hear over and over again is keeping the human in the loop. And in a different context where it's really important that the technology does not disrupt the adult who is trying to navigate in what he or she is doing on her own. So we need to assist without basically obstructing their view. And giving them the ability to annotate their maps, so we are doing audio breadcrumbs right now on maps that they can help annotate things in the ways that are useful to them. And also the notion of trusted sources where they can dictate who trusted sources are or become trusted sources to somebody else and how you can incorporate that information into providing useful guidance to the person. I'll put a final plug for some work we're doing with more traditional robots, so that as you might recognize, that's a Baxter robot. And we're now looking at how humans, blind humans can interact with robots and what that really means. So we've been running some studies on, we started with sighted experts who work with blind people, and it turns out they had very different ideas of how people who are blind might work with robots compared to the blind people, because it's not something anyone has done before. So they have these assumptions built in that aren't necessarily true. And it starts with things like, they'll say, oh, that's a very intimidating pose. Well, a blind person can't see the pose. They're not intimidated by that. So it's really interesting where we have usually in human-robot interaction, we start with sort of first impression. And the first impression for a blind person is somebody else describing the robot to them. So there's sort of a previous step than the robot introducing themselves. So we're trying to understand how best to describe robots to blind people, how a robot should then introduce itself. For example, a robot like Baxter is best, we found, to tell the person, I'm going to turn myself off, you can feel me. And here's sort of a map to feel me. And then when the person is ready, they trigger the robot turning itself back on, so that there is that less of an intimidation. And then there's, of course, the interaction and the follow-up. So I'm going to stop there. There are way too many founders and contributors and artists to thank, so I've listed a bunch of them there. But really, this is a huge effort by a lot of people and pulling together funding from a variety of sources. And we've been doing this for 10 years. It's been incredibly rewarding. And I've been excited to share it with you. So thank you.
Are there any questions?
Do all of the communities that teach Braille use this method for reading and writing has to be a
All the communities that teach Braille in the traditional method of state and status, yes. It's
So if they don't, you can just change the program on your system
exactly. The software can reverse it. So in the developed world where they type the same. They don't do it because you can type it that way.
I think there are other examples of this.
Absolutely. There are a variety of things we've been doing, including tactile graphics. It turns out that blind children in the developing world don't study science, geography, anything visually rich past about grade 7 if they're lucky. And so we've actually been tricking text braille printers to print tactile graphics, and there's a captioning automation issue that you have to work with. People use things in surprising ways. One of the teachers who's blind actually used that to train herself to learn the alphabet. And so she learned how to write her name in regular English so that she could go to the bank and sign her name. So it's really, I have so many stories. But thank you. I don't want to have to forget it. Oh, sorry, was that another question?
I did have a question. I was just curious, it's kind of a loaded one, but how do you sort of start these kind of projects? Like, I'm really interested in global security, so I don't know if you have any, how do you start?
Yeah, maybe we can have a longer conversation because there is no soundbite.